Stanford University.
Hello, this is Natalie Marine Street with the Stanford Historical Society Oral History Program. Today is April 6th, 2016, and I'm here with Arthur E. Bryson, Stanford University's Professor, Paul Pigott Professor of Engineering Emeritus. Professor Bryson arrived at Stanford in 1968 from Harvard, and he's held joint appointments in applied mechanics and aeronautics and astronautics. Professor, thank you so much for conducting this oral history with us today.
My pleasure.
I'd like to get started by asking you to tell us when you were born and something about the place where you grew up.
Okay, I was born in Winnetka, Illinois, and I went to school there through high school. What else do you want to know about that?
Yeah, well, tell me a little bit about your family.
Oh, I had, my father was an investment banker, and he commuted into Chicago from Winnetka on the train. And my mother was from Minnesota, and she was a wonderful, loving person. In fact, I had an ideal childhood, I would say. And I lived a half a block away from the ice skating rink where I spent most of my time in the winter.
Uh-huh.
And in the summer it was a park.
Right.
And then I was about a mile away from the beach on Lake Michigan. And I spent a lot of time there in the summer.
Right. Right.
So I had a very wonderful childhood.
So Winnetka was sort of like a suburb of Chicago then?
Mm-hmm. It's 16 miles from the center of Chicago. Okay. And the wonderful high school there, it's still wonderful. It's called New Trier High School. And that's an indication. Trier is a town in Germany. And when I look back, I realized almost all of my friends in high school were German descendants. So there was a big German movement there, I guess, during the French-German War, Franco-German War of 1870.
I see.
So that's how they came.
Right.
And so my best friend and my girlfriend were both German names, Kempfer and Seiler.
I see.
And so
right.
You don't know that when you're in high school. A name is just a tag, you know. And I had to realize much later in life that, my goodness, I was right in the middle of a big German community.
Right. Interesting.
Yeah.
So tell me a little bit about your father's work. So you said he was an investment banker?
Yes.
Did he work with a big firm?
He worked for a firm that's Halsey Stewart that sold municipal and state bonds. Uh-huh. And in particular, they were involved with Samuel Insull, who achieved some notoriety during the 1929 event.
Oh, right.
He had worked with Edison, and he had promoted the building of electric power plants, spreading the newly invented electricity that Edison had all over the Midwest,
right,
from Chicago outward into Iowa and down to Indiana and so on. And Insull got caught up in a I guess it's called I don't know what it's called anyway. He sold too many bonds to too many people.
Right.
And he got himself overextended.
Right.
And he was called on it, and he fled back to England, which he shouldn't have done. And he was brought back, and on trial, they exonerated him. They didn't.
And your father worked closely with him.
Closely with him.
So was this in your consciousness at all as a child, the events of the Great Depression? And
Yeah, it was, certainly was. I was in the basement working on my model railroad, and my father was working in a shop next room, and he had the radio on for the trial of Insul. And when he was announced not guilty, my father let out a war whoop. I never heard him do that before.
Oh, right.
Because it was very important to his firm.
Yes.
To not be incriminated by that.
Yeah. Anything else that you remember from that time? I mean, I would think it would have been sort of a stressful time if you were an investment banker.
No, it really wasn't.
That.
We were well shielded from that. And I would go on once in a while. I'd go on Saturday mornings. They worked 5.5 days. I'd go in with him to the office, and I'd go into the little room where they sent messages through the pipes. I forget what they call them.
Pneumatic tube?
Pneumatic tubes.
Oh, yes.
And so as a little boy, I'd sit there and take the incoming tubes and look at the address and put it into the right place to go. I had a lot of fun.
Oh, interesting. I always wondered about that system. Now, what about, did you have brothers or sisters?
I had a brother and 3 sisters, and I was number 4. My second oldest sister's passed away, but my 99-year-old older sister is in a retirement home in San Diego.
No kidding.
And my youngest sister is in Santa Barbara. My brother is in Milwaukee.
The Brysons are still going strong then,
Going strong.
Huh? And your mother, did she do any work outside of the home?
No, that was not much done in those days.
Yeah.
But she worked in the church ladies' fellowship and volunteered for things.
Right.
She was just a lovely person, kind and gentle.
And thinking back on those times, were there any indications that you would go on to be interested in mathematics and engineering and aeronautics?
Not a bit. My father shook his head when he realized I was pretty good at mathematics, because that was the one subject that he didn't do very well in college.
Yes.
So I don't know where that. Well, his mother, my grandmother, taught mathematics in high school in Pueblo, Colorado. So maybe that's where it came from.
I see. But you did model railroads. Was that a big hobby of yours?
Yes. We lived our house backed right up on the railroad, the Chicago Northwestern, the train that my father took to commute into Chicago. So trains are going by all the time. We didn't notice them, but when people would come and sleep overnight, they'd say, "What are those trains all night?"
Oh, right. Yeah. Interesting. And tell me a little bit more about your education. I think you had mentioned some teachers that had an impact on you.
Oh, my high school math teacher, Norma Slate, was a tremendous influence in my life. She was, I think, just maybe second or third year that she started teaching in high school. And she was full of enthusiasm, and I had her for 4 years because I was put into an X group, as they called it. Excuse me.
Yeah.
Which means experimental. And so we got the best teachers, and we were kept together as a group as we went through this big high school. And so I had her for 4 years for mathematics. And that really determined my direction in life.
What were they experimenting with? Keeping you together as a cohort, or?
I think experimenting to see if a special program for good students was a good thing or a bad thing.
I see.
I think nowadays they don't like that.
And it was just for math that you were kept together,
No,
or for everything?
Everything.
Oh, interesting.
Yeah, had 4 years of Latin, not with the same teacher, but it was just an excellent high school. It was ranked at that time in as one of the best public high schools in the country.
Interesting.
So I was very lucky.
Yeah. And so it was expected in your family that you would go on to college? Was that a
Oh yeah,
given?
my father had gone to college, first one in his family, and so he expected all of us to go. All 5 of us went to college, and he paid for it. But yeah, the college I went to start with was determined by my mother's relatives. I had I think it was a second cousin at Haverford College in Pennsylvania, who was a professor of English who taught Shakespeare. And so mother knew about that and suggested that as a good place to go, as a small college, liberal arts, and but it still had an engineering program. So you want me to start on the Haverford?
Yeah, so you were interested, you knew you wanted to study math then?
Well, no, I didn't. I was not interested so much in math as I was in engineering. And Haverford at that time had a small engineering department, just about 3 professors.
Yeah.
And they were good. And I had a wonderful math teacher who then went off to the service. This was during the beginning of World War II. And so I got when he left, they brought a teacher from Bryn Mawr, which is sort of the twin of Haverford, both Quaker colleges, just down the main line a couple of miles. And so I had this lady teacher who was a German Jewish refugee. And she had a thick German accent. We could barely understand her. And all the things that we found hard, she thought was trivial. But she was very good. She knew her stuff.
Yeah.
So that was quite an experience.
Do you recall her name by any chance? Do you recall her name by any chance? It's been a long time, but sometimes it sticks with us.
I should.
Yeah.
I should, because she later married Professor Richard von Mises, who was at Harvard.
Oh, interesting.
And in a way, I replaced von Mises, because, well, I should say that he retired when I became an assistant professor. And he had married this woman, and so that was a strange connection.
That is a strange. So you ran into her again then.
And then von Mises, I had a strange connection. He was Jewish and had left Germany in the 30s to go to Turkey. And in fact, a whole bunch of German Jewish professors went to Turkey to the school in Istanbul. And my professor at Caltech had von Mises as a teacher in Istanbul.
Oh, interesting.
Isn't that amazing?
Liebmann.
Yeah.
So we'll talk about him.
Yeah, we'll talk about it.
So before we move on, I want to go back to this time you're getting ready to graduate from high school. You're going to go off to Haverford. You have some family connections. And this must be right at the beginning of World War II.
Exactly.
So was that on your mind?
Very much so. I was a year ahead of myself in school, so I wasn't subject to the draft. I was 17 or 16 when I went to Haverford. And, but of course I was aware that it was hanging over my head that I was going to get drafted. So I finished 2 years at Haverford, and then I was 18 and I was subject to the draft. So I decided I would like to be a flyer. And so I signed up for the Navy V5 program, which would have made me a pilot, like President Bush. And so that didn't turn out because they had too many people who wanted to be pilots, and so they deflected me into the engineering program.
Okay, so the V5 program was was it like an officer's training, pilot training thing?
Naval Aviators Officer Training.
Okay, and then
so they directed me to V12, which then is deck officer training.
I see.
And since I had wanted to be a pilot, they assumed I would want to finish my work in aeronautical engineering. So that's how I got into aeronautical engineering.
Okay.
Yeah.
I wanted to ask you about Haverford and the Quaker Connection. And did that manifest itself during the wartime at any time? I mean, were
Oh,
there...
absolutely. I think a majority of my fellow students were Quakers at Haverford, and they're a wonderful people. And in fact, my freshman roommates, the Quakers, most of them were conscientious objectors.
Yes.
And so my roommate was, and he signed up for the ambulance corps, and he was killed in North Africa.
No kidding.
And there are many others who signed up to do dangerous assignments, like trying out new vaccines and so forth for the military. Many of them died there doing things like that. So they're brave people.
Yeah. And was that something that you ever considered, being in that
No, I
environment?
didn't. I was not of the Quaker influence, but I greatly admired the Quakers. In fact, when I was there, the top Quaker, I think, in the country was Rufus Jones.
Right.
And he was an emeritus professor at Haverford. And we had compulsory fifth day meeting. Fifth day being Friday. Yeah, Friday. And so we had to walk about a mile to the Quaker meeting house from the campus. And it's a silent meeting, except that senior people like Rufus Jones were encouraged to speak if they had something good to say. So he told us a lot of wonderful stories, which are sort of like little Bible stories, and his experiences in the American Friends Service Committee. He was an amazing man, just remarkable. And so there's strong Quaker influence there. One of my engineering professors was a Quaker, and he did work to help the native Indian tribes in the East. And they're nice people.
Okay.
Right.
So then you have to leave Haverford to go into the
Yes,
Navy,
after 2 years, I left, and the Navy asked me, gave me a list of places where I might go, and one of them was Northwestern, which was in Evanston, right next to Winnetka.
Oh.
So I signed up for Northwestern, and they gave me the Northwestern Missouri State Teachers College.
Oh my.
Which wasn't quite as good as my high school. So I spent, I think, just a quarter there, and now asked to be moved, and they gave me choice of Kansas State or Iowa State. Well, Iowa State was closer to home, so I picked Iowa State, and they moved me there. I didn't expect them to do that, but they did, and put me in an aeronautical engineering program at Iowa State, which is an excellent program, still is. And so that's where I met my wife. So I can thank the Navy for sending me there.
So I want to talk about Helen, but tell me first, were your brothers also in the service at this time?
Yes, my brother, my only one brother, he was in the Air Force.
Yeah.
And he was called back for the Korean War, so I wasn't called back. But he was not a flyer, but he was involved with being at the stations where they tell the pilots where to go. I forget what you call that. They direct,
like the air
directing.
control or something?
Yeah, air traffic control. Air control. And he was right up on the front lines on the border with North Korea.
Right. So tell me how you met Helen.
I first saw her across the chow line in the place, big Union, where the sailors had, the V-12 sailors had their meals. She was there a week early because she had a job in the testing office. Oh. And so she was the only girl on the other side of the chow line. So she walked along there trying not to make eye contact with all these sailors across from her. And I thought she was pretty cute. So I joined a YMCA quartet and came across her again in an audience at a church place where we were singing. And I got my 3 quartet members to sing right to her. So she was looking, who are they singing to?
Oh, no.
So after that, I got a date with her. And so
this is
that was the beginning.
That was it, huh?
Yeah.
And so this was like a barbershop quartet type
Barbershop
of
quartet.
Singing in? Oh.
If you've seen the that wonderful movie about Iowa, what's it called? There's a barbershop quartet in that.
The Music Man.
The Music Man.
Yeah.
And we sang many of the same songs they sing in The Music Man.
Right.
Only they were much better, of course.
Right.
It was a fantastic quartet.
Yeah. And she was from Iowa, Helen.
She was born on a farm halfway between Des Moines and Omaha. They had 5 miles out of the little town of Atlantic. And she was the third in the family, and there was 5 years between her and her brother. So she was essentially alone most of the time on this farm out of town. So she got very self-motivated and so forth. And she loved to read, and she'd go to town with her mother, and she'd go to the library while her mother shopped, and she'd get books. So she became quite a reader. She was fascinated by history, which turned up later when we traveled the world after I retired. And
Right.
she knew all the history of places where we were going.
Right.
But she was a very intelligent, curious person. And we were married for 68 years. Last 3 years, she was had Alzheimer's. So she was in an institution, but she still maintained her cheerful attitude. She didn't know who we were, like me or the kids, but she managed to keep upbeat.
Oh, that's amazing. Yeah. It's a tough time. So you met Helen there at Iowa State, and then they must have shipped you off somewhere.
They shipped me off to Notre Dame Midshipman School, and 4 months training there, and then to Alameda Naval Air Station, and here in California, just across the bay. I sent her an engagement ring from the ship's store and asked her if she'd marry me. She said yes.
Oh, wonderful. And then did she come and join you then?
No.
No?
She was a sophomore in college at Iowa State, and I didn't know where I was going to be.
Right.
So we got married after the war, after I got out.
Okay.
But
So paint the scene for me a little bit about Alameda, the naval station. I mean, what kind of things did they have you doing there?
I was in the assembly and repair departments, A&R as they call it. And there's several others, one in Hawaii, one in Panama, Navy A&R. And what we did was take the airplanes off the carriers coming back from the South Pacific, tear them down, look at every part, put them back together again, put in new parts for the old ones or so forth, put them back together, and then ship them out again the carrier. So I was involved in that. I was in the flight testing department of the A&R, and so I was looking right out on the flight line, and that's dangerous. These swinging propellers.
I see.
In fact, I witnessed a couple of guys get hit by swinging propellers, which is not pleasant to watch. And then we'd have, after we fixed these planes, the pilots would take the aircraft up to flight test them after, and fly them around the bay or out to sea. And I witnessed a crash there where somebody had left a desiccant bag in the intake to the air intake to the engine, and when he shifted into blower, it didn't work, and he went straight into the bay.
Oh my.
And so, dangerous work.
Yeah.
And the other thing I remember is my first night I had the watch. Being a lowly ensign, you get the 12 to 4 watch in the morning. And so I went out and I got my instructions to hail the sentinels. I didn't speak loud enough, apparently, to the first guy, and he put a shot over my head.
Oh boy. Oh.
I think he was playing with me. He knew I was a young ensign.
Oh, maybe.
And yeah.
Yeah.
I'd like to think that anyway. But
that'll stick
so
in
I
your
spoke
memory.
much louder to the next guy.
Yeah, I guess so. Let's see, what else about Alameda in that time?
Well, Alameda was the carriers. Not only had the carriers there, but they also had the big 4-engine flying boats that fly from Hawaii to Alameda, carrying personnel and messages and so forth. And so that was interesting too. They navigated by using a new system, which oh gosh, I forget the name of it now, but it had beacons down up at Point Reyes and another beacon down near Point Lobos. Mm-hmm. And these two beacons were sending pulses, and the airplane flying from Hawaii would be on determine the time difference in the reception of the signals,
right,
and determine his position from that very accurately.
Right.
In fact, they arranged it so that one of the constant time difference lines went right through the middle of the Golden Gate.
Oh, interesting.
and so they could pilot right over the
Right.
Golden Gate coming in.
Oh, that must have been something to see.
So I saw a lot of those. I saw the first jet planes being loaded onto the carriers to take out to the Pacific too.
Interesting.
Bell P-59.
Yeah.
They're very secret. I put them on the carriers at night so nobody could see them.
And had you flown in an airplane by this time?
No. Well, I flew in airplanes as a passenger, but I'm
Right.
not a pilot. And so technically I got outside the 3-mile line, so I got overseas pay, which is a fluke. But it was in a Vought, it was a Douglas dive bomber, which were used at the Battle of they were used all over the South Pacific. But I went as a passenger, only just for fun.
Right. So was that pretty typical as part of your job? You'd get to fly in these, in the planes that you were
working
but
on.
you were never got to be a pilot yourself.
No.
So, interesting.
Well, I did, actually. I flew when I was at Iowa State. They arranged for us to have Sunday morning lessons at the little local Ames, Iowa airport. And so I took lessons there and got to solo and flew about 5 hours solo.
Yeah.
So I had the experience of flying there.
Yeah.
Later on, my kids knew that I was teaching helicopter aerodynamics, so they gave me a birthday present of I think it was 4 hours instruction in helicopter at San Carlos.
Oh, interesting.
And the guy who was teaching me was, of course, a Vietnam veteran, and to him it was all just trivial. I said, "What do you think about when you want to move over from here to there?" He said, "I just think about being over there, and pretty soon I'm there."
Oh, interesting.
And so that didn't help me too much, but he knew that I had taught aerodynamics of helicopters, so he said, "Now, Professor, I'm going to put you out here in the marshy area over a tire that's been painted white, a tractor tire. You can see it very easily. Put you over the top of it, and you see if you can stay there." He was pulling my leg because I knew I couldn't. Because I sat there and I looked at the tire, and pretty soon I began an oscillation like this.
Yeah.
You can't look at the tire. You're 2 integrations away from position. You got to look at the horizon, and then which is velocity. You're only 1 integration away, and that works.
Oh, interesting.
And that was an interesting instruction in control.
Right. To get you.
But I finally got so I could land it. Landing is the hard part of a helicopter because you're coming in and moving your throttle forward instead of off, because you're going to hang from the rotor when you're just above the place you want to land.
Right.
But when you're up to speed and flying, it plays just like an airplane.
Right.
Yeah.
So do you have any memories about the end of the war?
Oh, yeah. I was, where was I? I must have been at Alameda. Yeah. And, of course, the atomic bomb, tremendous news when that was dropped. And argued about whether we should have done it on a test island and so forth before. But I think President Truman made the right decision, because he saved the lives of thousands, tens of thousands of American soldiers who would have had to storm the mainland in Japan. And we had learned by then that they were fanatical people. They didn't get captured. They fought right until they were shot. And didn't take prisoners very often. And because if they took prisoners and turned them back, they knew what would happen to them. And they were expected to die in place. So that was an interesting time, too. I went into San Francisco now and then from Alameda, and at that time they had a launch that went right from the air station across the bay to the ferry building, and or else we took the A train, which was on the lower level of the Bay Bridge, and I was allowed to wear the green aviator's uniform, even though I wasn't a flyer. So I got a lot of good experiences out of being in the aviator's uniform in San Francisco.
Oh, boy.
Like somebody would say, "Hey, would you like to go up and have dinner with me and my daughter in some town up in Marin?" Oh, yeah. We were about to take the bus. Fellow ensign would take a ride up to see Muir Woods. And he was, I don't know, they came by and saw us in the line and said, "Come on with me, I'll take you up there."
Oh, that's great.
So, and I was, one fantastic scene. I heard the Sixth Fleet was coming home on a certain date, and so I went up to Coit Tower, and there's a parking area up on the top there, to watch them come in, along with a great many other people. And as the carriers came under the Golden Gate Bridge, the sailors were all lined up on the deck, and they threw their hats in the air as they came under the bridge. It's a great day.
Yeah. Interesting. So the war's over, and what did you do next?
Well, let's see. I came back to Colorado, where my father had retired, and I climbed about half a dozen 15ers, as they call them, 15,000-foot peaks, with a friend of his who is a geologist. And so I learned a lot about rocks and things. He had a little geologist hammer. He'd break open a rock and find stones that you would never have thought of looking at. And then I got married in August after that summer, and went back to school at Iowa State, and I hadn't finished my bachelor's degree, so that was the first thing I did in aeronautical engineering. And in order to make a little extra money, I taught mathematics, applied mathematics. The GIs coming back after World War II had flooded the place, so they didn't have enough teachers.
Oh.
So Ernie Anderson, who was the head of aeronautical engineering and was now in the math department, asked me to come and teach. And so I taught mathematics there, and I learned a lot of new stuff, including the Laplace transform, which I'd never done before. And so then I got my degree in December of '46, and I stayed on to work on a master's degree in physics in order for Helen to finish her college. But I found I didn't like physics. I liked engineering. So after just a few months, we decided to get a job. And I got a job working in a paper carton factory in Philadelphia.
Oh, interesting.
Of all things. The Container Corporation of America, which was quite a visible company in those days. The owner was very interested in art, and he advertised. He did big ads in Time and other magazines featuring artists and so on. And he renovated the town of Aspen in Colorado by offering to provide paint, so you could get a uniform paint through the town, and then he built a lot of new things. And as you may know, Aspen soon became a skiing center for Colorado, but I forget his name now, but he was a remarkable guy. Well, I worked at that paper mill for about a year. I went to night school at Drexel in Philadelphia to learn how to make paper.
Oh my.
And I discovered it hadn't changed much since the Egyptian times. And I was assistant to the chief engineer at the plant there, and sort of a training program. But he was a remarkable guy. I went with him each morning to inspect what had been done. They had a big building program after World War II because they weren't able to do anything during the war.
Right.
So after the war, they built several new big paper machines, and these things are huge. They're a block long and 6 stories high. And so I was designing, since they knew I knew something about fluid mechanics, they asked me to design the ductwork, which went to the cylinders where the paper pulp was. This is a board machine. There's 6 cylinders which look like window. What's the name for the screen? Window screen.
Oh, right.
This look like window screens wrapped around a big cylinder, 8 feet long and 3 feet in diameter, and that dipped into the paper pulp, and then was pressed in by a felt on the top. That's the first layer, and they go 6 layers, and each layer was different. The middle ones were lower quality pulp. The other ones high quality. Then it goes to the dryers, which were 6 stories high, and there must have been 8 or so layers of them. The sheet of paper, which was then 10 feet wide, goes up over these dryers, which are steam heated, and like this. And so they had, I'm getting into too much detail, but it was fascinating because they had about 50 men sitting around waiting for a break in the paper.
Oh.
And that happened quite often. And when the paper broke, they just let it go down into a big pit below the paper machine and then tried to restart the paper going back up.
I see.
And by the time I left, they had got an automatic system for doing that, and the 50 guys got laid off.
I was going to say, it seems like there'd be a better
that
way.
It was really fascinating working there, but after a year, I said, I don't want to be a paperboard machine executive.
Right.
I would rather do aeronautics. So I looked in the one ad, so to speak, and got a job at United Aircraft in East Hartford, Connecticut. So we moved from Philadelphia to Connecticut, and I worked in a wind tunnel there. Should I go into some detail on that or not?
Yeah, tell me a little bit about it, and
Okay.
then we'll get on to Liebman.
This was our first high-speed tunnel that United Aircraft, which included Pratt & Whitney and Hamilton Standard Propeller and Chance Vought, had built. It was designed to go up to the speed of sound, and also to take engines, so they had to have an air exchange tower in the circuit of the air to exhaust the gas and suck in fresh air. Well, the first time they turned it on, everybody in Hartford, East Hartford, and West Hartford woke up. The noise was just tremendous.
Oh,
and so they hired a company to come in and soundproof the tower, the air exchange tower, just by putting Celotex in there. And that calmed it down. Well, then they started the tunnel up and it didn't work. Yeah. And the air was going through the test section and not following the walls. It was like a jet was going into the diffuser, they call it. And so there was a bright young engineer from Holland, Netherlands, who had an idea of putting little wings like this around the wind tunnel exit of the test section. And these little wings would produce a tip vortex, just like you see in the trails, vapor trails, and mix the high energy air with the bonded air so that it would follow the wall. It worked.
Oh, and you were there during this time while they were trying to work that out.
And then Boeing and Douglas adapted those too. They still use them, I think, in front of the control surfaces, the ailerons, to keep the ailerons from the air from separating over the ailerons. So that was I supervised half a dozen young women who had majored in math, and they had these old hand calculators to reduce the data from the tests we were making. And
do you remember what you called those women? Did they have a name in the job that they did?
we just call them computers.
Computers.
No. And they one or two came from Vassar, which was nearby, and they were good, very good. But
so they'd take the measurements and
the measurements
do calculations?
and then subtract the tares, as they call them, T-A-R-E, and make the corrections and plot them and so forth. No computers in those days, so this was all hand Marchant computer stuff, and so.
And it was a woman's job?
It was a woman's job.
No men.
Understood, no men.
And were there any female engineers that you ever ran across at that time?
Not at that time.
Yeah.
Met a lot since, but not at that time.
Very interesting. So you supervised the the data.
Data reduction, we called it.
Okay.
Yeah.
And did you start thinking about graduate school at this point?
Well,
how did that come about?
That came about because this is a new wind tunnel, and it went at speeds that were much faster than anybody had ever gone before, at least in the company there. And many mysteries. We came in one morning and the whole test section was full of fog. And we later learned about condensation shock waves. And then I happened to be in a bookstore in Hartford and saw a new book on high-speed aerodynamics of compressible flow by Liepmann and Puckett, which I bought and devoured. And it explained to me a lot of things that I had observed in the wind tunnel. So I noticed that they were both at, Liepmann was at Caltech. I'd never heard of Caltech before. But I said, that's a good place to go, and I've got this GI Bill, let's do that.
Oh.
So off we went to California, having our oldest child on the way in Iowa. And so we moved into really was a former Army barracks, which had been fixed up for graduate students at Caltech. It was in Temple City, about 5 miles from Caltech. It was right near the big Arcadia racetrack, and also near Amy Semple McPherson's temple.
No kidding.
And that's why it's called Temple City.
I see.
That's where she had her.
Yeah.
her
Did you ever see her?
No, I never saw her.
Interesting.
But so we had a 5-mile commute, but there were about 70 of us married students living there with kids, and
yours was brand new. I mean, did you plan on stopping in Iowa to have the baby, or was that a surprise?
that was a surprise.
Okay. So you have to tell just a little bit about that story.
Yeah.
That seems very important.
Yeah. Actually, Helen's father came to Hartford and drove her back while I worked for a while, and then I drove our Nash Roadster across the country, stayed with her till the baby was born, and then went on to California. Visited my father in Colorado. But so that was another change of of places to live, and it was quite tolerable because all of us had great expectations, being graduate students at Caltech, and so the fact that we had ice boxes instead of refrigerators, and the walls were so thin you had no secrets from your next door neighbors, so forth. It didn't bother us too much.
Yeah. And so did you apply to work with Liepmann directly, or was it
No,
how did that work?
My intention was to get a master's degree and go to work for Douglas and build airplanes. And but I apparently did fairly well as a master's student, and I got recruited by Liepmann to say, wouldn't you like to stay for a PhD? I said, well, I hadn't thought about that. But my GI Bill is running out. I don't think I can do it. But he said, there's some new fellowships from Hughes Aircraft. I bet you could get one of those. So I applied and I got one. So that paid for my last 2 years of graduate work at Caltech. And only thing I had to do was to go 1 day a week to Hughes, which is way across LA and Culver City, and then work there in the summers.
I see.
And that's how I got to work for Puckett, who was the other author of the book I had bought, Liepmann and Puckett. He was my immediate boss in the aerodynamics department at Hughes, and wonderful engineer. He later ran the whole operation at Hughes there.
So tell me a little bit about Liepmann. What was he like?
Oh, gosh. He's a little guy like me, even smaller, I think. And he was born and raised in Berlin. But when Hitler made his putsch in Munich. I think he was about 32 or 33. His father said, "We're getting out of here." They moved to Istanbul. His father was Jewish, his mother was not, but that would have not been good to stay. So that's so he went to college in Istanbul, and then he went to graduate work in Zurich, not the ETH, but University of Zurich, and did some PhD in physics. And then he came to the United States, and this must have been right at the end of the war, World War II. And so he worked for the Bureau of Standards for a year in Washington, and learned some wonderful swear words from his colleagues. And, then he came to he was recruited to Caltech, and by von Karman, who was a very famous aeronautical engineer, who was teaching at that time at Caltech. And so he worked pretty closely with von Karman. And he was just a remarkable, wonderful guy. I bonded with him right away, and he offered me a job working in his new wind tunnel, transonic wind tunnel. And it was being built while I was there, and it was finished. And then he had another graduate student who was building an interferometer to put on the wind tunnel to make optical observations of the models in the test section. Harry Ashkenas did that, and Harry didn't pass his orals, so he went off to Cornell, and I was left with this sensitive interferometer sitting on 4 tires that had been blown up, inner tubes, and so my job was to put it on something that would fit around the wind tunnel. Well, that took me a while. I'd never done anything like that before. It had the thing that the interferometer was on had to be isolated from the vibration, because the big motor that was running the wind tunnel was in the basement below and was shaking the floor. So I learned about vibration isolation the hard way. I had the box that the interferometer was on hanging by 4 springs with a required static deflection of 1 foot in order to get the vibration isolation. Well, the high frequency stuff came right through the metal springs. Didn't work. So I had the idea of putting model airplane rubber bands.
Right.
I put 12 of them on each corner, and they rub on each other and provide a nice damping, which the metal springs didn't have. That worked.
There you go.
So we were on our way. Well, that is a very sensitive instrument. It took me a long time to get it working with the floor vibrating and the wind tunnel running. But then I had a lot of fun working on my PhD thesis there in that wind tunnel.
Yeah. Now, did Liepmann sort of direct you to what problem he wanted you to work on, or did you have some freedom in your choice of dissertation topic?
I had, it's a half and half. He wanted me to do something in high-speed subsonic or low supersonic speeds. We could do both in this wind tunnel. And I picked, or maybe he picked, a 2-dimensional airfoil, which would have a shape that was just arcs of circle, called the biconvex airfoil. And so that spanned the test section, and we were looking parallel to it with the interferometer. And so I made an interesting discovery in the thesis there, which I didn't realize the importance of it until much later. But we found that the flow past this airfoil section at the highest subsonic speed we could go was identical to the Mach number distribution when we were at the lowest supersonic speed. And I thought, why could that be? Well, it's because if you're out in free flight and the airplane is approaching the speed of sound, it pushes out waves in front, and finally a big shock wave forms in front of it. And so on the line through the middle of that to the airplane, the air goes from supersonic to subsonic through the shock wave.
Oh.
So the airfoil thinks it's still in subsonic flight, even though it's going supersonic. And that's the reason why it has the same Mach number distribution as it did at subsonic speed. So that Mach number freeze was, I guess, the most important discovery I made in my PhD thesis. And then we began to, later on, when NASA got a lot of pictures on the internet, I found a picture of a fighter plane going right at Mach 1, taken with the sun behind it, and it's like a shadow. You could see the shock waves, and it just verified everything that I'd seen.
Oh, interesting.
Yeah.
Yeah. Now, what was sort of going on in aeronautics at this time? I mean, this was a little bit after Chuck Yeager, right?
That's right. Yeager had
Tell me
already
about that.
flown at supersonic speeds, and so, as in many cases, the theoretical and experimental understanding of things came after people designed things that worked.
Interesting.
So this is really an act of science rather than engineering, explaining what was going on. And that's useful for future, but it didn't have much influence in the transonic airplane design. It had already been designed.
Right.
And so.
And what did you think you might do after you got the PhD? Did you have any expectations about where this was going to lead?
Well, Hughes wanted me to stay and work there, and so I did. Offered me a nice salary, and we moved from the the barracks at Caltech to a rented house in Pasadena that looked down on the Rose Bowl, and I got into a carpool with 4 other guys who lived in Pasadena, and we drove back and forth to Culver City. And so we did that for 2 years and had a lot of exciting things happen there until the 2 leaders of the Hughes, Cy Ramo and Dean Wooldridge, decided to form their own company with Thompson Products and called it TRW, Thompson Ramo Wooldridge. And during that last year, things sort of slowed down at Hughes because they were saving interesting projects for their own company.
Oh, I see.
So a lot of us are sitting around kind of twiddling our thumbs, wondering what's going on here. Why don't we have something to work on? Well, at that point, it just again, a wonderful coincidence that Puckett invited one of his old professors from Harvard to come out for the summer. And he put him in my office.
Okay.
And he had just done some exciting work on turbulent transition in boundary layers on a water table. And I helped him a little bit writing a paper on the subject, which he kindly made me co-author of. And when he came to present it at a meeting in Chicago, he had some important thing to do at Harvard, and he called me up and said, "Would you present the paper?" So I went and presented the paper, and in the audience was the head of NASA, Hugh Dryden. And he was an expert on this subject of turbulence. And after I finished my paper, he stood up and said, "That's all nonsense."
Oh, no.
Utter nonsense. You're seeing something else that involves waves. Well, it turns out Emmons was right and Dryden was wrong. He went back, made experiments in air, found exactly the same thing. Emmons had discovered that turbulence transition takes place with little spots of turbulence starting in the boundary layer. And these spots begin to grow like that and then coalesce to form a complete boundary layer. Exactly the same thing happens in air. And the instabilities that produce these little spots were predicted by a German fellow, but they didn't realize that this was a prelude to the transition. And so that was a very important discovery.
Oh, interesting.
And well, that got me in good stead with Emmons. And so after World War II, Harvard was wanting to expand its engineering school, and he thought of me because he'd worked with me, invited me to come back there. And I was sitting there twiddling my thumbs waiting for Raymond Woodridge to do something.
Right.
So I said, okay, let's try
Sounds
Harvard.
Oh, interesting.
So off we go.
Yeah, so I want to back up before we get to Harvard and just ask you a couple of questions about Hughes. So what were you supposed to be working on but before things slowed down there? So I guess this is the early 50s, right?
I was working on, I guess one of my more important contributions there was the Falcon missile, which we were designing, had a cruciform configuration, 4 wings, and a crosses like this, and the controls, big, highly swept delta wings, and the control surfaces were on the trailing edge of the wings, and there were 4 of them on each wing, and they weren't working very well in the wind tunnel tests. Well, I don't know if I did it or somebody else helped me, but I figured out that the boundary layer was separating on the wings, those long wings, and so they weren't. The elevons were working in a boundary layer instead of a healthy airstream. So, and also at supersonic speeds, there were shock waves forming on the back side of the wing, which helped separate the boundary layer. So I suggested that they put a gap between the trailing edge of the wing and the elevons. And we tried that, worked beautifully. And the reason it was important is because they use hydraulic fluid to move the elevons. It was under high hydraulic pressure. And they had a big accumulator, which was filled with the hydraulic oil and then air on the other side of a diaphragm. And so if we hadn't figured out this way to reduce the hinge moment on the elevons, it would have run out of hydraulic fluid.
I see.
So that saved the day for that.
Right.
And
did you get to see it actually tested outside of the wind tunnel ever?
yeah, I didn't actually go there, but it was tested in Texas, New Mexico, just across on the boundary with Mexico. And I was charged with the duty of Puckett asked me to check the flight data to see if the wind tunnel agreed with the flight experiments. Well, to do that, I had to go through the control system, which I partially understood, but then I had to really learn how it worked, and in order to reduce the data. Well, we fired the first one from the ground. It's designed to be launched from an airplane, but we went from the ground and fired it at a aluminum foil-lined parachute. And I don't know if this was done deliberately or by mistake, but they aimed it 30 degrees off from going directly. I think they did it deliberately just to show how well the guidance system, because it turned right like this and went right through the center of the parachute on the first flight.
Oh,
And we were all sitting there in Culver City watching it on television from there. Big hurrah.
right.
So I made a model of the flight with three-dimensional model with a wire following the thing there, and then checked the hinge moments, and they agreed pretty well.
Oh, interesting.
Mm-hmm.
So were you guys conscious at Hughes of what the Russians were doing? Was this something that you thought about a lot?
We certainly were.
Yeah.
Oh, another thing that I did that was interesting was my first job that Puckett put me on. He said, nobody around here understands heat transfer, and our radome on the front of the missile, front of the radar receiver is burning up when we fire it. Go learn something about heat transfer and help us. So I was kind of miffed because here I'm expert on transonic flow, and here I'm doing heat transfer. But, that was a good thing. PhDs, when they go into industry, tend to continue doing their PhD thesis instead of working on the company problems. So I learned quite a bit about heat transfer and made some flight tests with thermistors at various depths in the plastic radome, and predicted the temperatures right on the button.
Oh, interesting.
So we understood finally what was going on.
Right.
And
okay, so about 1953 then, you get this offer to go to Harvard and back to academia.
yeah,
So tell me a little bit about that.
well, that, as I said, Raymond Wonders were in the process of moving away, and so things were kind of slow, and and I'd met Emmons, and he invited me back. So I said, let's do that. That'll be fun. So back we go. We rented a house in Watertown, which was owned by a couple from Maine, and the walls had grungy smoke and soot about an inch thick on it.
Oh boy.
And the bathtub would take an hour and a half to fill up. The pipes were full of corrosion. Anyway, we lived there and cleaned it up. Couldn't do much about the pipes, so we just had to plan ahead.
Right.
And
you have 2 children, or?
at that point, we had I had 3 children.
Yeah.
Janet had arrived while I was working at Hughes, the third one, and the fourth one was on the way. So Helen got used to putting what do you call them? Not ski suits, but
Snowsuits, maybe? No.
yep. The little suits that you put them when you want to send them out in the winter. What do you call them?
Yeah. Snowsuit or
Snowsuits.
trundle bundle or
Yeah.
something like that.
Anyway, that was something new to her because
Yeah.
in California you don't need those.
Oh boy.
So she did a lot of things. She was a great soldier. She put up with so much stuff from me moving around. And so then after a year, when we got established at Harvard, we bought a house in Lexington, which is a very nice suburb northwest of Boston and Cambridge, and moved in there. And within a year of being there, the big forest right next to us started to be developed by a developer to put houses, putting a new street in. And so I watched that, and I said, I want that lot at the top of the hill, and we'll build our own house. So we did. I went out and saw him on the property one day and said, I want to buy that lot. He said, okay. Put me down. It was the second highest hill in Lexington, and it had a view out over Boston looking eastward, and up to Stoneham going north, and to some town, Denham down below. Marvelous view over from the top of the hill there. So we built a house. I got an architect and built a wonderful, wonderful house, which was full of glass and things. And hated to leave that house, but
Yeah.
it was so wonderful. And the kids would have, in the winter, had a toboggan run through the woods down to the street below. It was just great. And so we were very fond of that house. But
Welcome change from the other
Yeah.
place, it sounds like. So tell me a little bit about what it was like to, enter this department. It was Department of Mechanical Engineering, right, at Harvard?
at Harvard,
Yeah. What was it like?
it was wonderful. They were so nice to me. They said, we'll give you some money to build a laboratory. We want you to do experiments like you did at Caltech and at Hughes. Ammons being my mentor
Right.
then. And so they gave me they had a new building full of labs, gave me a lab. I decided that I would build a shock tube, which is a device that produces a strong shock going down a tube, and behind the shock is a region of subsonic flow and supersonic flow, depending how fast you're going. And so I built this 40-foot long shock tube, which was about this wide and 12 inches high, made out of thick aluminum slabs. And I had a wonderful mechanic in the shop there who came from Maine and had a Maine accent. He was just terrific. He'd take my ideas and I just give him a rough sketch of what I wanted. He'd make it.
Oh, he'd figure out how to build it.
Make it right. So that really worked out very well. And my first student in an experiment was a German fellow who came to the United States on a NASA fellowship. This is part of the Marshall Plan.
Oh, interesting.
And his name was Gross, G-R-O-S-S. And so he came in and he worked. Funny story there. First day he got there, he came into the lab and he walked up to me, and I was standing next to my mechanic who was much better dressed than I was, and he walked up to him and said, "Professor Bryson, are you?" Oh no, this is the other guy. Anyway, I get out of track there. What was I talking about?
So you were talking about the shock tube that
Shock
you
tube.
built and the first students that you
really
had.
worked out very well. When I first started it, I left the end out on their side, so the shockwave came out of the end of the tube and hit the wall and nearly knocked the wall down.
It did knock the wall down?
No, it didn't, but it sounded like it was going to. And so I didn't do that anymore.
Yeah.
But we made some experiments on the diffraction of a shock wave over a sphere. So we had a sphere in the test section, and the shock wave came and went over it, and we took pictures of it with a spark, or was it a BH? It was a spark, or a BH6 lamp flashing. And so we could take pictures of a microsecond length, millionth of a second. And so if we took enough of those, we could get the whole diffraction history of the shock going over the sphere. Incredible complicated flow as it goes over the thing. And by coincidence, some British aerodynamicist had just published a theoretical version of that. And so we compared his theory with our experiments right on.
Oh, interesting.
And he later went to Caltech and taught there. But
what was the practical concern with this particular shockwave and what were you hoping that it would solve?
Well, I wanted to use it as a way of producing high-speed flow and I would put models in there and check the flow and check them against predictions. That's what I wanted to do. And we did that. Rolf Gross was his name, this German fellow, did a very nice job on a thesis there. He went to work for a company in Los Angeles afterward.
Right.
But before that, he was married. He brought over his girlfriend from Germany, and they had a baby, and tragedy struck. They were driving up in New Hampshire, and they didn't have baby seats in those days. And they had an accident, and the baby was killed.
Oh, no.
So that was tragic.
Yeah.
But he went on to California and did some very nice experimental work at, I forget the name of the company, Aero something. But
Anyway.
yeah, where were we?
Yeah. So at Harvard at this time, how did the funding work? Did you have to go out and like get grants and things like that to earn your keep there?
That's a good question. No, the lab and the shark tube were financed by Harvard, which was, it's unusual for universities to do that. So my first experiments were done completely financed by Harvard. They also built a darkroom in the lab so that I could develop the photographs we were taking. Later on, I got some grants from NASA, and one of my students worked on Emmons, got grants from Pratt & Whitney. He had worked as a consultant and then got some funding from Pratt & Whitney because he worked in engines and thermodynamics. So I was very lucky to get support from Harvard and Howard Emmons's contract with Pratt & Whitney. I don't remember having any NASA money. No, that's not right. I did one theoretical thesis. The first one, my first PhD thesis, was a calculation of the flight path of a missile being launched from the ground, going up against an incoming bomber at 20,000 feet. And Stanley Ross was my first PhD student. And the first computers arrived at Harvard about that time, and they were in the math department. And so Professor Burkhoff had one, and so I got to know him and asked if I could have an hour's time on his computer to calculate this flight path. This was an optimal path. It maximized the velocity at the end of the flight. I got into optimization. I forgot how I got to tell you how I got into optimization at Hughes, but I did. And I had this problem in my pocket when I came to Harvard. I wanted to solve this one, and so Stanley worked on it, and so he got this time on Burkhoff's computer, and later on I checked it with more modern computers, and it was right on. He did a good job.
So this was a big machine then at this time?
On a bigger machine, yeah.
Yeah.
And in fact, I could do it on my home computer when, by the time
Right.
I reviewed it again. And so it wouldn't have been a PhD thesis, but
Right.
it was let me go back and tell you how I got involved in optimization.
Yeah.
At Hughes. We were firing at the New Mexico, Alameda was the name of the base in New Mexico, which is right on the border with Mexico. And the range safety officer there said, what would happen if your Falcon missile got away from you and flew on its own over the border and into Mexico? And so Puckett said, "No, okay, it would be going supersonic, probably twice the speed of sound by the time it got over the border. Art, go figure what the maximum range of the Falcon missile would be if it wanted to go as far as it could. So this was an optimal programming problem, and I had an office mate who was a top applied mathematician, Dick Edwards, and so he formulated for me as a calculus of variations problem. I'd never heard of the calculus variations till he told me about it. And we tried to solve it on the analog computers. We didn't have digital computers in those days. But you can't solve a two-point, if the two-point boundary value, you get boundary conditions at both ends of the flight. And it's very difficult on an analog computer, whereas digital computers, not a problem. So I put that problem in my pocket, and that's the one that I gave to Stanley Ross
I see.
when he came to work for me. And yeah, that was certainly interesting.
Yeah. And so is this with Raytheon, where you work at Harvard? Were you also doing some work with Raytheon?
I took half the salary at Harvard that I was making at Hughes. Again, my long-suffering wife put up with that. But I said, well, maybe the first summer or two I will work in industry and make some extra money. So I applied to Raytheon, and again, I'm lucky in my timing. They had just started to build the Hawk missile. It hadn't been built, hadn't even been designed. So I got in there with Tom Phillips, who was the chief engineer on the Hawk missile. And he was very interested in my experience at Hughes with the Falcon missile, because the Hawk looked very much like the Falcon, just twice as big.
Right.
And so I suggested to him that he go out and talk to Puckett, and he did. And Puckett generously, well, it's government property anyway, gave him the wind tunnel data. And so no coincidence, the Hawk looks just like the Falcon, but twice as big. And they had hired, since Raytheon's an electronics company, they hired Northrop, a few engineers from Northrop, to come do the aerodynamics on the Hawk missile. And they didn't know, they'd never built a cruciform missile or anything supersonic. So I was in the catbird seat on that one. I knew more than these three guys from Northrop about that missile. So they put me in charge of a lot of interesting things there at Raytheon, and including designing the rocket engine for it, which had to have two levels, a big pulse to take off and then a sustaining one to just keep it at constant velocity. So they wanted a solid propellant rocket that had two layers of propellant in it. The first layer was fast burning, high thrust. Second layer was the slow. So you had to design the geometry of the star shape, where you start the burning, so that it's constant area as it burns through the first one, and then constant area burning through the second one. So it's an interesting mathematical problem to design the star shape to do that. So I designed that, and it worked. And they sent me down to Huntsville, Alabama, where Thiokol was building the rocket. And so I worked with them on building that rocket. And
yeah.
No, I got lost again.
Yeah. So we're at Raytheon. So I'm just trying
Raytheon.
to situate us historically. So what's happening? Have we had Sputnik yet by this time? And
Sputnik
talk a little bit about the
Sputnik
context.
arrived the first or second year I was at Harvard. Must have been about 55.
Yeah.
And we watched it go over in the morning. And
what did you think?
Wow, they're ahead of us. And that's, of course, exactly what the government thought, Congress. So they started giving money and contracts to everybody who, let's catch up with the Russians.
Right.
And So that was a very important thing.
And then I imagine, you're doing this work on missiles, and around 1963 we have the issue with the Cuban Missile Crisis, right?
Yeah.
Am I got my years right? So what were you doing during that time, and was your expertise called on
I didn't have
at
much
all?
direct connection. I was just a spectator, but Kennedy, I think, did the right thing there. We intercepted the ships that were carrying the missiles coming to Cuba from Russia, and almost started a war right there.
Yeah.
And it's lucky it didn't. But before that, they had been flying planes over, taking pictures of the where they're building the launch facilities for the rockets. So they knew what was coming. So that was a bold decision by President Kennedy to actually send our warships out there and stop that ship that carried the missiles to Cuba.
Right.
And
so did you feel like you were a cold warrior at all? Was that motivating you?
That was really dangerous. That could have been developed into a hot war at any time. And so we had our fingers crossed.
Yeah, yeah.
As I'm sure President Kennedy did.
Yeah. Many people remember that time very vividly.
Yeah. It was Khrushchev, I think, at that time, who came to the UN, pounded his shoe on the desk.
Right. Well, let's talk just a little bit more about Harvard. Anything else about Harvard? I mean, what kind of culture did the department have? What kind of a place was it to work?
It was wonderful. I had such wonderful colleagues, and the whole atmosphere of the place, of course, was just terrific. I would go to the faculty meetings, and here would be Galbraith and other prominent people testing President Pusey. That those two got into a few fights on the faculty meeting floor because Galbraith thought he knew more than Pusey did. And kind of arrogant. But so that was fascinating to see that. And Helen and I got invited to dinner at President Pusey's house one time, which was quite an event. The Dean of Engineering, Harvey Brooks, was a wonderful man. He was a guy who, well, he didn't hire me. The previous dean is the guy who hired me, who was a fellow named Van. We called him Van. It's just short for Van to something. And he was a physicist, actually. They'd put him in charge of engineering because they didn't, I don't know why they did that. But he was a wonderful guy, and I know why, because then he hired a bunch of solid state people, which was state-of-the-art research at that time. And solid state became all the transistors and electronics that we have now. So they were right on that. And Harvey Brooks spent a little too much time in Washington, in my opinion. He's a very nice man, and he was a great citizen for the country because he helped plan things in Washington. But things in Cambridge sort of fell in the cracks while he was off in Washington all the time. So I got a little unhappy with him. And then, of course, the Vietnam War came along, and the students were upset about everything, the war in particular. So they began to give us a hard time.
This is at Harvard.
In the engineering school. And so I said, well, I got an offer from Stanford at that time, and I said, well, it may be better out there. It wasn't. I went from the frying pan into the fire.
Yeah.
But also, I had the back of my mind, I loved California. I'd gone every summer out to work at either Boeing or Hughes, and I liked the West and the Sierras, hiking,
Right.
climbing.
Right.
So when the offer from Stanford came along, I'd spent a sabbatical year at Stanford from Harvard, and it must have been 71. You could check the date, but sabbatical year, they offered me a job to come out, and I was still happy doing what I was doing at Harvard, so I went back. But then when the war protests came, and my desire to move west came together,
Right.
we moved.
Right. Let's take a break and then we'll talk some more about that.
Okay.
Okay.